Hi, I'm Ms. Hall, and this is Lesson 1, Part B, Parent Functions and Transformations, Vertical and Horizontal Shifts and Reflections. Okay, we'll begin by reviewing what we learned in the previous lesson, which was given a parent function. Let's use the quadratic, so x squared. We discovered what happens when you shift different attributes of this x squared. For example, if inside grouping symbols you subtract 3, what you're actually doing is shifting the parent function 3 units to the right. And if instead inside grouping symbols you add plus 3 to the x value, you are shifting the parent function 3 units to the left. The general form of these horizontal translations is what we do to get the new function g of x is we take the original f of x minus h, is that we affect only that x value, by h. And so you can see in the minus 3, h is equal to positive 3, right? It's minus h, so it's minus 3. And that's why it's 3 units to the right. And in this next example, if we get it in the same form of x minus h, well, this would be x minus negative 3 to end up with x plus 3. The h value here is negative 3, and therefore it's a shift 3 units to the left. Okay, at this point you could also graph them and just make sure you understand and see these shifts happening. Let's go on to vertical translations, right? So this is shifting the graph up or down. This is perhaps the most straightforward one, is that you take the original function and if you add any amount to it, you are shifting up that amount. In this case, we are shifting the graph up 3 units. And if we have x squared minus 3, we are shifting the parent function, the parent graph, down 3 units. And the general form here is that to perform a vertical translation, that is shifting the graph up or down, you take the original function and you add or subtract k to it. In our first example, k is 3 units up. In our second, k is negative 3 units down. Now finally, reflections, which we only touched on in the previous lesson. There are 2 types of reflections. There's a reflection in the x-axis. So if you think of a graph, this is x squared, right? Here's the x-axis, so a reflection of the x-axis. And what that does is you take negative the function. We're going to see this more in example 2. Another way of what you're looking at is negative the y values, just changing all the y values that were positive to negative, all those that were negative to positive. And a reflection in the y-axis, well, that's not super interesting when we're looking at quadratics because that is the exact same function, right? You just think of like folding on itself, a reflection in the y-axis, it folds right back on top of itself. And here, the general form is we are negating the x values. Example 1, writing translations of functions. Let f of x equals 2x plus 1. A, write a function g whose graph is a translation 3 units down of the graph of f of x. So we're going to have a function g that is a vertical translation 3 units down. So what we want is we want the original function minus 3. Right? This is our k value here is negative 3 if we're going to shift down 3 units. Let's rewrite this as g of x equals, well, I'm going to replace f of x with 2x plus 1. Because that is the equivalent of f of x equals 2x plus 1, so I can replace it. And then I'll do the minus 3. And now, I actually don't need parentheses, there's nothing I'm distributing, but I do it just to be safe. And I can now take away the parentheses and combine my like terms, and I get 2x minus 2. And this is a translation of f of x down 3 units. B, write a function h whose graph is a translation 2 units to the left of the graph of f. Okay. Left is the h value, and then to the left is going to be negative 2. So they want this new function to be h, and I am going to do f of x minus my h value. My h value is negative 2. I can rewrite this as f of x plus 2. And now I'm going to take the original function, but instead of putting an x, I'm putting an x plus 2. So anywhere there is an x, I'm replacing it with x plus 2. And now I can distribute this 2, and I get 2x plus 4 plus 1, and h of x equals 2x plus 5. Example 2, writing reflections of functions. Let f of x equal the absolute value of x plus 3 plus 1. A, write a function g whose graph is a reflection in the x-axis of the graph of f. My new function is going to be g of x. This is a reflection in the x-axis. I need to make myself a little note. So this is the x-axis, and I've got to think to myself, so if I have a point up here, which is x comma f of x, and I want to reflect over the x-axis, what changes? Well, the x value does not, but the y value, or the f of x, negates. So I can write that this is the negation of f of x. Therefore, g of x equals negative, and let me copy down the function, the absolute value of x plus 3 plus 1. I distribute that negative sign. So now I have g of x equals negative the absolute value of x plus 3 minus 1. I can stop there. That is a reflection of f of x in the x-axis. Now, B, write a function h, I know it's going to be h of x, whose graph is a reflection in the y-axis of the graph of f. So I'm going to go back to this original point. So if I have this point x comma f of x, and I want to reflect over the y-axis, the only thing that changes is the x value. F of x stays the same. So I'm going to do f of negative x. I just want to change the x value. Therefore, I have h of x equals the absolute value of negative x plus 3 plus 1. Right? Instead of f of x, I now have f of negative x. So anywhere I see the x, I'm going to replace it with my negative x. And that's how I end up with h of x